Hello, let's talk about symmetric difference of two sets. So suppose we have two sets A and B. Let's describe what is the symmetric difference between them. We can say the symmetric difference is this expression here in blue or in green, right? You can use either one of those, but I have to show at least once that the two ways of calculating the symmetric difference will give us this exact same result. Okay? So, proposition, this expression in blue equals to this expression in green. The left-hand side equals the right-hand side. To prove that, I'm going to show that the left-hand side is a subset of the right-hand side in step 1. And then in step 2, I will prove that the right-hand side in green is a subset of the left-hand side. Okay, this inclusion here. And if one side is a subset of the other and the other is a subset of the first, the two sets have to be equal. Okay? That's the strategy of the proof here. So first part, let's show that the blue set, the left-hand side, is a subset of the right-hand side. To do that, pick any element on the left. Let x be any arbitrary element on the left-hand side, and we're going to prove that x must be an element of the right. So every element of the left has to be an element of the right. It means the left-hand side is a subset of the right-hand side. So that's the idea. Pick x belonging to this in blue. If it belongs to the difference between this set and this set, it means that x belongs to the union, A union B, and x does not belong to the intersection A intersection B. Okay? So x belongs to the union of A and B means that x belongs to A or x belongs to B. That's this part. X does not belong to the intersection of A and B means that x does not belong to A or x does not belong to B. Okay? Now the tricky part. Let's suppose we have to have this and we have to have that square brackets here. Okay? So let's say x belongs to A. This bracket here has to be satisfied, but we already said, assume that x belongs to A, first case, right? So in this case, this is not true. So this must be true. Okay? When x belongs to A, x cannot belong to B. That's this case here. That's this possibility. Another possibility, if x does not belong to A, this has to be true. I have an and, so this whole chunk here has to be true. So if x is not an element of A, x has to be an element of B. If x is an element of B, this has to be true. And we know that x is an element of B, so this is wrong, this is false. So this must be true. So if x is in B, x does not belong to A, which is this case here. X is an element of B, x belongs to set B, and at the same time, x does not belong to set A. Okay? Now, if x belongs to A and x does not belong to B, x belongs to A minus B. Or, I repeat, this is true. X belongs to B and x does not belong to A means x belongs to B minus A. So if this is true, or that is true, well, x belongs to the union of this set and this set here. But that in green is exactly my right-hand side. So here I started with a generic element on the left-hand side and proved this element must be an element of the right-hand side in the first part of the proof. Now let's go to the second part of the proof. Pick any generic element of the right-hand side. X belongs to A minus B, union B minus A. If X belongs to this union, then X belongs to this set or X belongs to this set. X belongs to A minus B or else X belongs to B minus A. Okay? What does it mean to say that X belongs to the difference? It means that X belongs to A and X does not belong to B. And when x belongs to B minus A, that means that x belongs to B and x does not belong to A. Okay, the difference. Now, one of these two things must be true. At least one of the two must be true. And of course, both cannot be true at the same time because we cannot have x belongs to A and x does not belong to A at the same time. So exactly one of the two square brackets will be satisfied. Okay? Suppose that is this on the left. So x belongs to A and x does not belong to B. Well, if x belongs to A is true, this is going to be false. And x doesn't belong to B, this is going to be false. Okay? So x will belong to A is one, and x will not belong to B is one possibility. The other possibility is the other way around. X is in B but not in A. Okay? So in all cases, x belongs to either A or B, and we know that either this is going to be true or this is going to be true. We know that x does not belong to B, or else x does not belong to A. Okay? If x belongs to A or x belongs to B, means x belongs to the union of A and B. And, I repeat the and, x doesn't belong to B or doesn't belong to A, so it doesn't belong to the intersection. If it were to belong to the intersection, it would belong to at least one of A and B, and here we have that it doesn't belong to either A or B, so it doesn't belong to the intersection. Okay? And now I have x belongs to this set, and x does not belong to this set, therefore x belongs to the difference between this set minus this set. And exactly that's the expression here in blue. X belongs to the union of A and B, but does not belong to the intersection of A and B. So that's exactly what I wanted to show. I started with a genetic element of the green set and proved this genetic element must be an element of the blue set. Therefore, the right-hand side is a subset of the left-hand side. Now, we have by part 1 that the left-hand side is a subset of the right-hand side, and by part 2 we know that the right-hand side is a subset of the left-hand side. Therefore, the two sets are equal to each other. Okay? And we're going to look at the Venn diagrams here. In blue, I have the union minus the intersection. So the union, I would be in these regions here, but I have to remove the intersection, so I have to remove this part here. So the expression on the left-hand side means this region here and this region here. The expression on the right-hand side here in green, it's A minus B, so which is here, this region, union with B minus A. B minus A is this region here. And I take the union, so I take this or this. You can see by the picture, both are in the same, exactly the same set, right? The same region. And this is called the symmetric difference. If you like, you could write this as A delta B. So when you're calculating A delta B, you're calculating the symmetric difference, and you can use this expression, or you can use this expression, whatever is more convenient for you. Okay? Hope this clarifies the symmetric difference. Thank you. Bye-bye.